on the screen. So let's start with problem number 1. So it says, a small plane takes off from an airport and rises uniformly at an angle of 4 degrees with the horizontal ground. Can you envision that happening? Can you see an airplane taking off from a runway? You have that in your head? What would that look like on a piece of paper? So here's my runway. Here's the ground. And my plane is taking off, let's say in that direction. All right, now here's the fun part. How are we, let me try to draw an airplane. Ooh, this was much better than first period. The cockpit.
You gotta draw a detailed interior of the cockpit, not missing a single button or dial.
There we go.
There's my wing. There's my other wing.
Yeah, there you go.
There we go. All right. I'm improving in my. I'm really good at drawing trees. You'll come to find my trees are exceptional. My planes not so much. All right. So a small plane takes off from an airport and rises uniformly at an angle of 4 degrees. Where am I going to put that 4 degrees at? This little angle down here at the lower left, right? So, airplane takes off, angle at 4 degrees. It says, after it has traveled over a horizontal distance of 600 meters, what is the, bless you, the altitude of the plane? So now keep in mind, all these problems are going to be right triangles. So now I'm going to turn this into a right triangle by dropping that leg down from the plane to the ground. Where does the 600 meters go? It's traveled over a horizontal distance of 600 meters. So down here at the bottom, right? 600 meters, horizontal distance. And I want to find the altitude, so where am I going to put X? On the leg or the hypotenuse?
The leg.
The leg. Good. The other leg. That tells me how high the altitude is of the plane. So now I've got a right triangle with 1 degree, 1 side length, which means we're going to use trig. We need to figure out which trig function we're going to use. So I have my reference angle. 600, is that hypotenuse, opposite leg, or adjacent leg? Adjacent leg. X would be the opposite leg, so which trig function are we going to use? Tangent. Good. So we're going to set up the tangent of 4 degrees is equal to x over 600. Go ahead and solve that right now. Devin's plane's looking much better than mine. I say that's about equivalent to my plane sketches. Now we're rounding to the nearest foot. What do we got? I got 42 meters.
Oh, I got 419.
The tangent of 4 is 0.0699 equals x over 600. Put that over 1 when you cross multiply. 0.0699 times 600 is 41.94, which if I'm rounding to the nearest meter would be 42 meters.
I rounded up.
See where you made your mistake?
That's why I said 419, because I missed the dot.
Did you use 0.0699? times 600. Yeah, probably missing a 0. Okay, so there's number 1. Airplane. Done. Number 2, now we're going to go from the air to the sea. All right, so we've got a ship that sailed from a port. All right, well, here's my port. Looks like a pretty good port, huh? Okay, so a ship sailed from a port with a bearing of south 22 degrees east. So what direction is our ship going if it's going southeast? Down into the right? So here would be your path of your ship. There's my ship. So a ship sailed from a port with a bearing of south 22 degrees east. How far south has the ship traveled? So my south line would be a perpendicular line straight down. So that's my X. How far south has the ship sailed after it traveled a distance of 327 kilometers? Where's that 327 going to be if that's the distance that the ship itself traveled? It'll be the hypotenuse, right? The angle line. So 327. What's my degree? 22. Where am I going to put it?
Up on the top.
Up on the top. So 22 degrees. All right, so now let's figure out which trig function we are going to use. X is hypotenuse, opposite, adjacent. Adjacent, good. And hypotenuse, so it's the cosine of 22 degrees equals adjacent, so X over 327. Go ahead and solve that. And again, we'll round to the nearest kilometer. We're getting 303. You guys getting that number? 303 kilometers. So that means that they traveled 303 kilometers south, if that was the actual bearings. Does anybody need to work that out? You got it? All right. So we were at the air, sea. Now we're going to land, number 3. So we have a ladder on a fire truck. Oh, all right, okay, fire truck. Here we go. Here's my fire truck. Fire truck. Well, actually, fire trucks don't have a front end, do they? They're just flat in the front, aren't they? You got a little bumper? All right, so there's my fire truck. And then we have the ladder on the fire truck that's going up on an angle. All right, so a ladder on a fire truck can be turned to a maximum angle of 70 degrees. And it can be extended to a maximum length of 25 meters. All right, so where am I putting those two bits of information? Where's the 70 degrees going to go? In between the ladder and the truck. Good, so there's my 70 degrees, which means there's my right triangle. Where's the 25 going to go? It says the ladder can be extended to a maximum length of 25 meters. So on the actual ladder, which is the hypotenuse, right? It says the base of the ladder is mounted on a fire truck 2 meters above the ground. So the base of my ladder is really 2 meters already above the ground. So how high above the ground will the ladder reach? Where's my X going to go?
The altitude.
Opposite leg or the adjacent leg? The opposite leg, good. So X is going to go there. So we've got opposite and a hypotenuse. So which trig function are we going to use?
Sine.
Sine, good. So the sine of 70 degrees is equal to X over 25. Sine of 70, either using your table or your calculator, 0.9397 equals X over 25. Put that over 1 and cross multiply it. And we get X equals 23.5.
Plus 2.
Yeah, so good. So Riley, remember to do that. So this length right here is 23.5 meters. But it already is starting 2 meters above the ground, which means I have to add that extra 2 to it to get 25.5 meters. Good. All right. So we're going to stay with land. My favorite object to draw, a tree. That's probably because I'm best at making a tree out of my fire trucks and airplanes. All right, so from the tip of a shadow by the vertical object such as a tree. Okay, tree. Here's my tree. Ah, beautiful tree. So my tree has a shadow. So here's my shadow along the ground. So from the tip of the tree's shadow to the angle of elevation to the top of the tree, elevation to the top of the object. So I'm making a line going all the way up from that tip of the shadow up to the top of my tree. So from the tip of a shadow by the vertical object such as a tree, the angle of elevation of the top of the object is the same as the angle of elevation of the sun. If the angle of elevation is 21 degrees, where's that 21 going to go? 21 degrees is going to go in which angle?
Angle over here.
This lower angle right here, good, so 21 degrees. And the tree is 7 meters tall. So drop down your perpendicular part. So 7 meters is the height of my tree. I want to know how long is the shadow. So where is X going to go? Where's the length of the shadow? On the bottom. So I'm going to put X down there on the bottom. All right, which trig function are we going to use? Tangent. Yep, hypotenuse is not in play, so that eliminates the sine and the cosine. So now it's going to be the tangent. So the tangent of 21 degrees is equal to 7 over x. So the tangent of 21, 4 decimal places, 0.3839 equals 7 over x. Put it over 1. That gets me 7 equals 0.3839x. Divide by the decimal. 0.839. Matt, I see you're already working on in the back of the room. What are you getting?
18.2.
Thank you. So 18.2, what my units were meters. Would be the length of your shadow. Now let's think about this for a second. As the sun sets and rises, right? So as the sun's moving, if this degree keeps getting larger, what would happen to the length of your shadow? Would your shadow get smaller or larger?
Smaller.
So as my degree goes up, wouldn't that bring my shadow in? And as the sun goes down, your shadows get longer, right? Did you ever notice that before? That's how sundials work. Isn't that interesting? No, not interesting at all. All right, last one. Now we're back to our airplane. Bring it full circle. All right, now our plane took off. Now it's going to land. So our plane is flying at an altitude of 1.5 kilometers. So here's my airplane. I feel like I'm getting even better each time I do this airplane. Here's my airplane. Oh yeah, look at that. Has an altitude of 1.5 kilometers. That means it's 1.5 kilometers high. It's going to descend to an airport. There's my airport tower. So it's going to descend into an airport so that the path of the plane makes an angle of 5 degrees with the ground. Where am I going to put that 5 degrees?
Where the tower is?
Where the tower is. So 5 degrees. How far from the airport, which is the horizontal distance, should the descent begin? Where am I going to put X? On the bottom or the hypotenuse? How far from the airport in horizontal distance?
Oh, bottom.
The bottom. Good. Okay. All right, so which trig function are we going to use? Hypotenuse is not in play, so that leaves us the tangent of 5 degrees is equal to opposite, which is 1.5 over x. Tangent of 5, either using the table or your calculator, gets us 0.0875 equals 1.5 over x. Cross multiplying that gets us 1.5 equals 0.0875x. Divide it. So 1.5 divided by 0.0875 is about 17. Yeah, 17. What are we in? Kilometers? Okay. All right. So you